Okay, so we're moving on now to forces, and we're trying to find the resultant of two forces. So let's take a wee look at what it says here. It says, often we come across situations where two or more forces are acting together. The overall effect of these forces is called the resultant. The resultant is a single vector that would have the same effect. If two forces P and Q, you can see the wee tiny arrows at the end there, act on a particle as shown, then we can find the resultant force using the triangle law. Effectively, this is called putting the forces tip to tail. We can then solve for P and Q using the sine rule and the cosine rules. If they happen to be at right angles to each other, we could use Pythagoras and simple trig. Two forces acting on a particle have magnitudes 8 and 3. If the angle between their lines of action is 60 degrees, find the resultant force acting on the particle. Here's the way you want to try and think about this. If I give you a bird's eye view of two people pulling on something, let's say they're pulling on a chair in the classroom, and one person is pulling with 3 newtons in this direction here, and then acting at 60 degrees to that, someone's pulling with 8 newtons. I should have made that a lot longer, sorry, to make it a little more visual. Then we know that it heads somewhere in this direction here, so it wouldn't head exactly halfway, so the chair's not going to go this way here, it's going to go more towards the 8 one, and that's what we're trying to work out the actual direction in it's going. So our system for that, if we have two forces, is we put them then tip to tail. So what I'm going to do is I'm going to do the 3 newton one, and then on the end of it I'm going to stick the 8 newton one acting at 60 degrees. So that's 3 and that's 8. And let's have a wee think about this then. If that's 60 degrees, then the angle in here, because that's a straight line, is going to be 120 degrees. And the resultant force goes from the start of the first one to the end of the last one. And so we're looking for the length of that line there, and we're trying to find the angle that it goes at along like that. That's the resultant force and that we're looking for. So if two people are pulling on a chair, this is your bird's eye view of it. One person pulling with 8, one person pulling with 3, one person pulling with 8. It's going to go this way here. There's the direction it's going to go. We want to try and find the direction to the 3 newton force and try and work out our angles in from there. So that's where we're going. So we're going to use the cosine rule first of all to find the length of this line. We have 2 sides and we have the angle in between. So let's first of all go for that. So we are going to write a squared equals b squared plus c squared minus 2bc cos a. I'm just going to change this pencil here because it's annoying me. What we're looking for then is r, so r squared equals 3 squared plus 8 squared minus 2 upon 8 upon 3 cos 120. If you put that into your calculator, this square plus this square, take away this, you end up with 97. To get r then, we take the square root of 97 and it gives us 9.85. That's the answer then to 3 significant figures. Find the resultant force acting on the particle. We don't have too much space in for the next bit, but we should be able to work it out. So we now need to find the angle theta. So to find the angle theta, we're going to use the sine rule. I will left myself a whole lot of space here, but we should be okay working down here. So we're going to go for, because we're trying to find an angle, let me see, I'm going to go for sine theta, one opposite then is 8 equals sine 120 all over r, which in this case is root 97. See the way I've kept that a little bit more accurate there rather than write 9.85. Hopefully that makes sense to people. That means sine theta is sine of 120 all over root 97 multiplied by 8. Stick that all into your calculator, you will get 0.703, and if we do shift sine, then theta is going to be 44.7 degrees, and that of course then is the 3 significant figures. Now, a lot of the time in mechanics we give our answer and then we write a wee statement at the end. So here's what we found. We found it's 44 degrees here, and that's acting to the 3 Newton one, so it'll be 44 degrees up then from that. As we suggested, it was more than halfway because the 8 is going to have more effect than the 3, and that's what we have. So resultant force is 9.85 newtons at 44.7 degrees to the 3 Newton force. Hopefully that makes sense then for everyone.